Hello, and welcome to this session on averages. I'm Ravi Handa, and my Twitter handle is not so imaginatively named @Ravi Handa. You can provide your feedback over there or just connect with me if you wish to. Today's session is the first session in arithmetic portion of the preparation. We'll discuss average, weighted average, and assumed average and deviation in today's session. To begin with, what exactly is the average? Average is nothing else but if you sum all the elements and you divide it by the number of elements, what you get is the average of those elements. What I mean by that is, let's say if you have 1, 3, 5, 6, then their average is going to be 1 plus 3 plus 5 plus 6, their sum divided by the number of elements that you have taken, which is 4, which comes out as 1 plus 3 is 4 plus 5 is 9 plus 6 is 15. So 15 by 4, or the average comes out as 3.75. A related concept is of weighted average. Well, let's say if you were talking about the marks that you scored in 4 different tests were 1, 3, 5, and 6 out of 10, then your average score was 3.75. Weighted average comes in handy in a slightly different case. Let's say you talk about a class where 5 students got 4, 6 students got 7 out of a test, 8 students got 10 on 10. Then what is the average score? Now, in this case, what you can do is, well, add 4 plus 4 plus 4 plus 4 plus 4 5 times for the 5 students. Same thing for 7 and the same thing for the 8 students here. Instead of that, you can do the weighted average calculation, which is given by this formula. This formula is nothing else, but it makes your addition faster. So I know that 5 students got 4. So the total marks scored by them were 5 into 4, or that is the weight that you assign to the mark 4 is 5 because 5 students got that. Very similarly, 6 students got 7 and 8 students got 10. So these were the total marks that they scored. How many students were there in total? 5 plus 6 plus 8. And this calculation will lead us to my average score, which will be 20 plus 42 plus 80. I'll divide it by 80 and 20 is 100, 142. 142 needs to be divided by 5 plus 6 plus 8, or 19. So the average score that I'm looking at is 142 by 19. And this we have calculated by the weighted average method. Another method which is used for calculating averages is the assumed average method. Now, before I go ahead with the assumed average method, what you should first understand is deviation. What exactly is a deviation? Say, let's look at the above example again. 1, 3, 5, and 6. The average was 3.75. Let me just note down here 1, 3, 5, and 6 were the values, whereas my average was 3.75. Then the deviation of the first value 1 was 3.75, or rather 1 minus 3.75 was the deviation, that was minus 2.75. The deviation of the second value was 3 minus 3.75, which is minus 0.75. For the third value, it was 5 minus 3.75, which was 1.25. And for 6, the final value, the deviation was 6 minus 3.75, which was 2.25. These were individually the deviations. The deviation is nothing else but the difference of any particular value from the average. Why is it important? Well, if you notice here, the sum of the deviations will always be 0. Deviation from the average. As you can see here, given by the formula d x1 minus x average, x2 minus x average, x3 minus x average. You continue till n, sum of all these will be 0. Which leads me to a very important formula, that is x average, or the average for any particular set. You can assume an average, look at the deviation and divide it by the number of elements, and you can get to the answer. Well, let me just take a simplistic example on this. Let's say scores of a cricketer in a few matches are 62, 68, 50, 49, 40, 54, 43, 5, 96. Now, to calculate the average for all these, what will you have to do? To calculate the average for all these, what you'll have to do is, first of all, 1, 2, 3, 4, 5, 6, 7, 8. You will have to add these 8 values and divide. That is one method. By solving it the assumed average method, let's say that I assume the average to be 50. I've taken this randomly just so that my calculation is a little easier. And now I look at what is the total deviation from 50. 62 minus 50 is 12, plus 68 minus 50 is 18, 50 minus 50 is 0, 49 minus 50 is minus 1, 54 minus 50 is plus 4, 43 minus 50 is minus 7, 5 minus 50 is minus 45, and 96 minus 50 is plus 46. So these are my total deviations from the assumed average of 50. Let's see how this will lead to the actual average. This I can calculate very easily. I have a minus 1, a minus 45, and a plus 46. They will cancel out each other. So let me first cancel these. Then I have a 4 minus 7, which is effectively 0 plus 4 minus 7 can be written as minus 3, whereas a 12 plus 18 can be written as 30, or the total deviation, as you can see very easily, I have calculated it as 27, and this will lead to my actual average. My actual average will be nothing else but 50 plus 27 by 8. And that will lead me to my answer. 50 plus 27 by 8 is 427 by 8, which is roughly 53 will give me 424, 53 3 by 8, or 53.375. As you can see here, or I have very easily calculated the average without actually doing the cumbersome calculation of adding all of them up. So this method, as you can see, will reduce a lot of time in calculating averages. With this, I'd like to wrap up this session. If you have any feedback, please connect with me on Twitter, where my Twitter handle is @ravihanda. You can also email me on my mail ID, which is ravihanda@gmail.com.